the first two questions, it wants me to label and list all my corresponding parts. So it labels the triangle TUV. That means I want to go in order and mark up my angles. So I have 1, 2, 3, and then the second triangle goes in order from G, F, E. So that means angle T is congruent to angle G, angle U is congruent to angle F, and angle V is congruent to angle E. Okay, then I also need to label my sides. So in between the 1 and 2 angle mark, those two would be the same. In between the 2 and 3 mark, those would be the same. 2 and 3. And in between the 3 and 1, those two sides would be the same. So I want to go list those off. So I have TU is congruent to, I went from the 1 angle to the double angle, so I want to do the same thing over here. So it's congruent to GF. Then I have UV, and it's congruent to, from the 2 to 3, so FE. Then I have VT. Where did I get a W from? So I went from 3 to 1, so I want to do the same thing, so EG. Okay, then I want to do the same thing on the next triangle. So it goes in order. It goes from L, M, N, and it goes R, S, T. So I have my angles as L is congruent to R. Then I have angle M is congruent to angle S. I have angle N is congruent to angle T. Then I want to go find my sides. So this is my first mark I'm going to do in between the 1 angle and the double angle. So over here it's going to be right there. So I have LM is congruent to RS. Then I want to do between the 2 and 3. So I have MN. And then from 2 to 3 here is ST. And I have from 3 to 1. So I have NL on my first one, and 3 to 1 over here is TR. I want to remember that for my, if I'm giving, So if I'm, things I want to look for on a proof that'll help me work out pieces that are, more pieces that are congruent, is I want to look for the reflexive property. And this helps me find additional congruent sides. This is when I have two triangles that are together like this. The reflexive property gives me the side that they share in common as congruent. Then I also have vertical angles. And this helps with angles, showing that they're congruent. This is the one where it looks like a bow tie, and the two diagonal angles are congruent. Okay. Then for things that I'm given in my proof, I am given, the proof will tell me something's a midpoint. So if it tells me a midpoint, that's going to help me with my sides. So an example of this would be like two triangles like that, and then saying M is the midpoint of A and B. It would give me the congruent sides right there. Okay? Bisect works the same way, but bisect can work with angles or sides. So bisect could be like this, where it cuts that angle in half. That was supposed to go with the angle picture, so I'm going to go white it out. So that would be bisect with an angle. Bisect with sides would be something like where it would tell me that it bisects this, kind of like I had in the picture above. Okay. If it tells me lines are parallel, I can use this to find angles. Specifically, I'm going to do this in a different color. So corresponding angles can be found when the triangles kind of look like this. It's where they match up on the two parallel lines. Then I also have alternate interior. And these are the ones where they can be like in a bow tie shape one, and they'd be right here on the parallel lines. Okay. I am writing way too big, this is going to go down. So then I also have quadrilaterals. They give me sides, two sets of sides, quadrilaterals. And these could be anything that are, I could have, this word, I could have squares, I can have rectangles, and parallelograms for this to work. Okay. And then if I'm told something is perpendicular, so like right here, it gives me right angles. Okay. The CPCTC is, just kidding. Corresponding parts of congruent triangles are congruent. This is used to prove angles or sides. Okay. Then we also have our triangle congruence theorems that we can use. So these would be these are when I know three things about the triangles, and I can use these to prove that the two triangles are congruent. So I have side angle side, I have angle side angle, side side side, angle angle side, and those are for normal triangles. And then the last one I can use is hypotenuse leg, and this is for right triangles. I can spell triangle. Okay. So this one wants me to prove that the angles in the triangle sum to 180 degrees. I'm going to start off by writing my two columns. So I have statements and reasons. I want to start off with my given. AC is parallel to BD. Okay. So I have these two triangles showing me that they're parallel. Then I know angle 4, angle 2, and angle 5 equal 180 degrees because they are making the line because they are making the line BD. So this is definition of a straight line. Let's fill it in. There we go. Then the next thing I can say, so I know this is parallel and this is parallel. So if I look at this triangle, this would be a transversal. So using that as a transversal, I can see angle 4 and angle 1 are congruent. And this is based on alternate interior angles. And then if I look over on the other side, orange, BC is another transversal, and this time it works for angles 5 and 3. Oh, probably wanted to mark these. This is still alternate interior angles. Okay. Then, looking at my triangle, I can say, because all of these are congruent, I can start replacing things up in this proof. So instead of saying angle 4, I can say angle 1. And then I have nothing to replace 2 with. And then instead of 5, 5 is the same thing as 3, so I can just replace that with 3. And this was done by substituting those in. Okay. This one wants me to prove that the base angles of an isosceles triangle are congruent. So I want to start off with statements and reasons. So I am given AB is congruent to AC. From this picture, I can tell that AD is going to be congruent to DA. This is the reflexive property. Then, sorry, then I have that angle BAD is congruent to angle CAD. And this is by constructing the angle bisector of BAC. So now if I look at my two triangles, I have a side, an angle, and a side. So I can say the two triangles are congruent. I have triangle BAD is congruent to triangle CAD. I still want to prove that angle B is congruent to angle C. And then this would be by CP, CTC. Corresponding parts of congruent triangles are congruent, because now that I've proven that the two triangles are congruent, any of their angles are going to be congruent. Okay. So on the next one, I'm given that I'm given that ABCD is a rectangle. And I want to prove that triangle ABD is congruent to triangle CBD. So I start off with my given, ABCD. It's a rectangle. That's given. Then I'm going to have AB is congruent to CD by definition of a rectangle. Yeah. And I'm going to do the same thing with BC and AD. Also, definition of a rectangle. Then if I look at this triangle, they share the line in the middle. So BD is congruent to DB. This is the reflexive property. So I have 3 congruent pieces on this triangle. They're all of them, sorry, all of them are sides. So this is this side, side, side. And I can say my proof that triangle ABD is congruent to triangle CDB. Okay. The next one is giving me D as the midpoint of AB and telling me AC is congruent to BC, and then I want to prove my 2 angles are congruent. So if I'm proving triangles are congruent, I want to end with my congruence theorem. If I'm proving angles or sides are congruent, I'm going to end with CP, CTC. So that was given. And then I also had AC is congruent to BC. So I want to mark that one up. When it tells me D is the midpoint of AB, it's telling me it's cutting A and B in 2 equal pieces. So I'm going to have AD is congruent to DB by definition of midpoint. Then I can say that CD is congruent to CD by the reflexive property. So now I have 3 things in common with both of my triangles. So I can say the 2 triangles are congruent. So I have ACD is congruent to triangle BCD by side, side, side. Now that all that's left is I have to prove my angles are congruent. And I know that both the triangles are congruent. So I can just take their pieces and say they're congruent by CP, CT, C. Now that I have what they wanted, I am done. Okay. This one is giving me the bow tie, and it just wants me to prove that 2 triangles are congruent. So I have AB is parallel to CD. That's given. Remember, this symbol means parallel and not congruent. So all this is telling me is they are going in the same direction. Okay. Then I also have BC bisects AD. Okay. So when it tells me something is a bisector, it tells me it cuts it in half. The thing being cut in half is AD. So I have AE is congruent to DE by definition of bisect. Okay. I can also tell, because I have parallel lines, that this angle and this angle will be congruent. That's by, so remember, so these are parallel lines, and this would be my transversal. So they would be congruent by alternate interior angles, and I can just say angle A is congruent to angle D, alternate interior angles. Okay. Then I can also tell that these 2 angles that are across from each other, because it's a bow tie, they are going to be congruent. This would be by vertical angles. So I have to label these with 3 letters because angle E is kind of ambiguous and I don't know what it would be. So I have angle AEB is congruent to angle DEC. And this is by vertical angles. Now I have three things in common between my two triangles. I have an angle, a side, and an angle. So that's angle, side, angle. And I can say triangle ABE is congruent to triangle DCE. That D looks like an O, I'm sorry. Okay, for my last one, I am given that angle A is congruent to angle C, and that BD bisects angle ABC. So I want to start by writing off my givens. Angle A is congruent to angle C. And I mark it up on my picture. Then I am told BD bisects angle ABC. That's given to me. So now if I want to use that BD is bisecting ADC, bisect means cuts in half, so it's cutting that angle in half. So I can say angle ADB is congruent to angle CDB, and this would be by definition of bisect. Then I can also, from looking at this picture, I can tell that BD is going to be congruent to DB because it's the same line. So this is the reflexive property. Now I have three things in common with my triangles. So I can say triangle ABD is congruent to triangle CDB. And the reason would be I have an angle, and then a side.